Hello everyone, I hope everyone is doing well. I welcome you all to our YouTube channel. Technical Pilot is your co-pilot to the world of aviation. Whether you are dreaming of the skies or starting to prepare for your DGC examinations, I can assure you that you have taken off in the right direction. So let's not waste the time further and let's dive into today's topic now. There was a scientist whose name was Bernoulli. He did great work in the field of fluid dynamics. Fluid means anything which can flow. Air, liquid, both of these are fluids. So when any fluid moves, what will be the effects? He did great work in that field. What he said, he used the basic principle जो आपको भी पता है, that is fundamental law of universe. क्या energy and mass of this universe is constant. It can neither be created nor be destroyed, can only change from one form to another. पढ़ा था आपने बचपन में. Mass of this universe is constant. आप या तो मास को इकट्ठा करके एक बिल्डिंग बना सकते हो या उस बिल्डिंग को तोड़ सकते हो, लेकिन मास को डिस्ट्रॉय नहीं कर सकते. Any particle can be broken down into small particles, but you can't destroy a particle. Or you can combine the particles to form a bigger unit, but you can't create mass. Same with the energy. You can transform the energy from one form to another, like mechanical to heat energy. Energy can transform from one form to another, but you can't destroy or create energy. He used the same principle. He said that let's take a tube and some fluid is entering into this tube. The area at the entry is A1 and the fluid which is coming into the tube is coming at a speed of V1, at a velocity of V1. Now he said that the tube is such that area of the tube is increasing. As we move further, area of the tube is increasing. Now area at the exit section, let's call it exit. This is the entry. The area at the exit is A2. Obviously, I can see A2 is more than A1. The velocity of the gases which are coming out is V2. They are coming out at a speed of V2. Bernoulli said that if mass of this universe is constant, mass can neither be created nor be destroyed. Whatever mass is going in per unit of time, the same mass must be coming out per unit of time. In 1 second or 1 minute, whatever mass will enter into the tube, the same mass has to come out, because mass can neither be created nor be destroyed. There is no any other way through which mass can go out, no other entry point, no other exit point. Mass is neither getting accumulated inside the tube, because if mass starts accumulating inside the tube, after some time the tube will get blocked. I am considering that mass is not getting accumulated. So can I say whatever goes in, the same is coming out? Mass per unit time at entry is equal to mass per unit time at exit. Let's call this section as section 1 at entry and the section 2 at exit, so that I don't have to write the entry and exit word again and again. Okay, you know, density is defined as mass upon volume. Yes or no? So I write mass as density into volume. So I replace mass by density into volume. Per unit of time at section 1 is equal to density into volume per unit of time at section 2. Now I take a unit volume. I take a volume of small portion here. At the entry section, I take a small volume. Now, do you agree that this is kind of a cylinder? The volume of the cylinder is pi r square, that is area of this face, into length, into height. Agree? A small volume at section 1 will be equal to a small volume. Similarly, I'll take a small volume at section 2 as well, a small length L2 into pi r square. Area of, I can write volume as density into volume is pi r square, that is A1, into length per unit of time at section 1 equal to density, volume is area into length. At section 2 area I have taken A2. I have written formula of volume only, area into length. Now length per unit time, what is that? Distance per unit time, velocity. So I can write it as density into area A1 into velocity at section 1, velocity is V1, equal to density into area A2 section 2, velocity is V2. And 1 और 2 को हटा के let's write density at 1, density at 2, rho 1 and rho 2. This equation is defined as Bernoulli's principle of continuity. Now, एक बात और नोटिस करें आप that whatever fluid is going in, हमने उसके पैरामीटर्स लिए rho 1, A1 is the area obviously and V1 is the velocity at which it is going in, and the fluid which is coming out density 2, area A2 and velocity at which it is coming out is V2. Do you think the density will change? The same fluid is coming out, right? We can consider the density as constant, ρ2, obviously under certain assumptions when compressibility error is not there at low speeds, when the speed of the fluid is lesser, whatever speed you will be flying the aircraft, you can consider density constant. Okay, compressibility error, theoretically we say at above Mach 0.4 compressibility error will be there, but actually significant compressibility error is when you are flying at Mach 0.8. So I can consider density as constant. If I consider density constant, I can cancel out the density rho 1 and rho 2. Both are equal. What I am left with? I am left with the equation A1 V1 is equal to A2 V2. And this is known as, again, Bernoulli's principle of continuity or Bernoulli's equation of continuity. It is the simplified version. Simplified. And we will use this equation for understanding aerodynamics. A1 V1 is equal to A2 P2. Do you understand the derivation? Everyone, note down किया आपने derivation? Derivation देखो जरूरी नहीं है. I agree. We need only equation to solve the questions. But equation को समझने के लिए basic concept समझना जरूरी है. You must understand the concept to understand this equation. This is highly important equation. A1 V1 is equal to A2 V. We saw this equation in the engines as well, right? While studying engines, and at that time I told you that please remember this equation for the moment. We will discuss about it in detail later. We will use this equation in aerodynamics. You can't do aerodynamics without this equation. Bernoulli's principle of continuity, Bernoulli's equation of continuity. मैंने देखा that if I take a tube, then I find the equation. If I take section 1, section 2, I find that the product of density, area and velocity at section 1 is equal to product of density into area and velocity at section 2. If you take any section along the tube, you take a section here, section 3, section here, section 4, you take any section along the tube, what you will find? You will find that product of density into area into velocity at section 3, product of density into area into velocity at section 4, all of these are same. You have done the derivation at 2 points, section 1 and section 2, you can take any points along the tube. Always the product of density into area into velocity will be equal. I can say this is constant along the tube. The product of area into velocity, product of density into area into velocity along the tube is constant. Does not change. What was it originally? Mass per unit time. That means I can say mass per unit time at each and every section is constant. This is called mass flow rate is constant. I can say the statement along a tube mass flow rate is constant. That is product of density into area into velocity. If density is reducing here, mass flow rate should reduce. When I say the statement mass flow rate is constant, इसका मतलब ये नहीं है यूनिवर्सल ट्रूथ हो गया. आप कहीं भी कभी भी कहीं भी किसी भी एटमॉस्फेरिक पैरामीटर पे चले जाओ मास फ्लो रेट चेंज होगा ही नहीं, ऐसा नहीं है. अंडरस्टैंड माय पॉइंट. Mass flow rate is constant along the tube. Okay. अब आप कोई ऐसा पैरामीटर चेंज करते हो जिसकी वजह से मेरी डेंसिटी चेंज हो गई, तो मास फ्लो रेट विल चेंज ऑब्वियसली, बट along this tube it will remain constant. Density is reduced at each and every section. Along this tube, mass flow rate will remain constant only, but due to density, due to change in temperature, mass flow rate will be changed from the previous one. And now as it is changed, it will remain constant. Let's say earlier mass flow rate was 50 at section 1, 50, 50, 50, 50. Now as the temperature is increased, mass flow rate will be maybe 48, 48, 48, 48. Understand the point? What's the meaning of change in mass flow rate? Mass flow rate is mass per unit time, density into area into velocity. Okay, density into area into velocity, and we have seen that this is constant at all the points across the tube. Across the tube, you take any section, doesn't matter. You take any section, mass flow rate, mass per unit time, product of area into density into area into velocity will remain constant. At this section, ये बोल रहा है कि area is 1 meter square. At this section, area is half meter square. Can you tell me please, if here the velocity is 104 meter per second, can you tell me the velocity v2 please? Consider density as constant, ρ1 equal to ρ2. Area is reduced to half. Whatever is area A1, A2 is half of that. Can tell me the relation between V1 and V2. I have told you V1 104 meter per second. Tell me V2 please. V2 is 208 meter per second. So means you have doubled the velocity. बिल्कुल simple यार. A1 V1 is equal to A2 V2. The product is constant. If I am saying that this is half of A1, then obviously to get the product equal to A1 V1, I must increase the velocity 2 times, then only it will cancel out and I will get it same as A1 V1. Yes or no? यार अब करके देख लो, V1 निकाल लो यहाँ से. V1 is equal to A1 V1 upon A2. If one parameter is half, other must be doubled, then only the product will remain constant, product will remain same. यार मैंने बोला मेरा प्रोडक्ट आना चाहिए 50, मैंने बोला 2.5 into 20 gives me 50. Everyone agree? I am saying I still need the product 50, but I double this value. What will happen to this value? By decrease by half. Why half? Because the first one is doubled. First one is what? 2 into 2.5. So you must do second value as half of 20, half of 20, so that this 2 will cancel out. Understand the point? Everyone? In order to get the constant product, we must increase or decrease the second parameter by the same value by which you have done the first parameter. You have changed the first parameter. Chalo, good enough. So the velocity, acha, here he took 52 meter per second, so it is double to 104. We have taken 104, ours will be double to 204. Dekho, he is saying that at section 3, now area is doubled. Now consider A2 and A3. A2 V2 is equal to A3 V3. If area is doubled, what will happen to velocity? Velocity will get half. V3 will half of V2 if the area is twice of A2. Okay. Mass flow rate will remain constant. I hope you understand the point. A1 V1 is equal to A2 V2. ठीक है, आपको ये इक्वेशन याद रखनी है, अपने दिमाग में प्रिंट करनी है. This equation you won't be able to understand further. Thank you everyone for watching this video. Stay tuned to learn about DGCA subjects, aviation concepts in a more simplified way. And if you have any questions, please feel free to drop them down in the comments below. Do not forget to subscribe so that you are updated with the latest videos. And please follow us on Instagram @technicalpilot.in. Thank you. See you next time.